Press pause. Let's try this question a bit more integrated this time, or just what we just learned. Press play when you are ready. So here we have a set of parallel lines once again. Let's look at this. So we have a triangle within this set of parallel lines, and let's think what we've just learned so far, the last few questions, or back to basics. So our base is 73. This is bottom left. If you look at this line over here, this triangle, it looks like this line over here, it looks like a line like this. Similarly, this line over here looks the same like that, if it helps you, okay? So going back to this, and this is 73, bottom left. This has to be 73 as well. They're both called alternate angles. So 73 and alternate. That's good enough for that. Angle Y. So if Y is over here, well, 124. If this is 124 over here, again, we could say that this angle here, they're both supplementary. They both add up to 180. So 124, or 180 take away 124 rather. This will give us 56. That is your answer, 56. And the reason why, simply state what it is. Supplementary. Press pause, write this question down, parts A and B. Try to find the exterior and interior angle of this regular polygon, and press play when you're done. So this question is setting up on the basics of this whole topic, interior, exterior angle. So part A, what is the exterior angle? So exterior angle means this basically, okay? It basically means that if we pick one, let's say, vertex over here, or one corner, let's say we do a straight line jutting out of each one in the same kind of way. We'll try to make them straight. It's pretty hard over here, but we can do this. There we go. So they all kind of go in the right-hand way, right-hand side rather, like that, okay? Exterior means this. Now, if you were to look at one of them, let's pick one. Let's pick this one over here. It's the right-hand side of this, okay? We keep doing the same side, the same kind of direction for each one of them, like this. So this is exterior. All these yellow bits add up to 360 degrees, okay? Now, it's worth saying that this is a regular polygon. It's a six-sided shape, so more specifically, this is a hexagon, a regular hexagon, okay? And the sum of all these yellow bits will have to add up to 360 because we're turning around 360 degrees. So the sum of exterior angles has to add up to 360 degrees, and this works for both regular and irregular shapes. Regular means a shape with the same sides and the same angles. Irregular means obviously the opposite. It hasn't got that. So this is what all these yellow bits add up to. Therefore, one exterior has to be, common sense wise, 360 divided by how many sides? We have 6 in this case. It's got to be 60. So make sure you understand that. It's quite self-explanatory. In fact, we prefer always to work out the exterior angle first. Even if they give you an interior angle, you'll see why in a second. The exterior angle always comes first. So let's bring us to our second question over here. What is the interior angle of this shape over here, this regular hexagon? So interior is quite more intuitive. It just means the inside. Let's say that bit, okay? It can mean all of these actually, but we'll just... yeah, okay, we'll put them all there so you understand it, okay? It means all of these. Let's pick this one maybe over here, this little bit over here. Let's go a bit more in depth with this, perhaps. Let's look at that. Okay, now, interior and exterior. Now, you're probably looking at this and thinking, it looks like, hey, a line, okay? This is a line over here, from here to here. Let's say we were to zoom in like this. So we've got this over here as well. Now, this is the green one. This is the interior, and this is the exterior over here, let's say. It's not the scale at all, but that's a basic way of understanding this. So if it's a straight line, you should be thinking a straight line adds up to, you've guessed it, 180 degrees. So why do we say pick the exterior first? If the exterior is 60, if this is 60 degrees over here, this has to be 180 take away the exterior, which is 120 in this case. So therefore, interior plus exterior has to equal 180 degrees. That's a second formula. You should take note. This is not given to you in any formula booklet, this one or this one over here. So take note of both of those. The answer for this question, by the way, would be 120. Okay, so look back at this and make notes on this. Let's try to answer parts A and B, find the perpendicular bisector and the angle bisector of these two parts. Press play when you're ready. So angle bisector comes up a lot. It means the locus that is equal distance from points A and B over here. So let's get a compass and let's put a point on point A here. Let's open it over halfway. Okay, it doesn't matter how much over halfway it could be, 3/4, 2/3, but it's got to be this over halfway like that. Let's draw a semicircle from this. It could be a full circle obviously, but we'll do a semicircle in this case. And now let's put our point on point B. And let's do the same width as you had that compass. Don't open and close it. Do the same width as it was before, roughly over here. Then what we do is draw another half circle like this, as such, and we have it looking like this. It looks kind of like a fish. And then you draw a line between them, and hopefully it's halfway, and it's going to be as well 90 degrees as well. So this is very approximately, obviously it's not really halfway as you can see, but the basic gist, you've understood how to do this, that's the main thing. So everywhere on this black line is the same distance from points A and B. Let's now do the angle bisector. So let's draw a line bisecting this. That's always equal distance from these two lines over here. So point, step one, the 3 steps for this. Step one, let's put a compass over here, point 1. And let's draw a circle. It doesn't matter how long the circle is. Let's just draw it like this. Okay, obviously draw a full circle if you want to. Let's now pick the points where it intersects these two lines. It could be this point or the bottom line. We just pick this point over here. And let's draw another circle as such, like this. Obviously, it could be a bigger circle if you wanted to. Point 3 over here, where it intersects this point. And let's draw another point over here. That could be a bit more like that, let's say. And this would be roughly like this over here. Then what we do, we get a line and we're going to join this bit to this. And that is an angle bisector everywhere on this grid line. Is exactly the same distance from, let's say, this line over here, 1, 2, and this line here, 1, 3. Press pause. Let's write this question on similar shapes. Let's answer A and B. Press play when you're ready. So A, B, and C, and P, Q, R are similar triangles. Similar shapes basically mean the same shape but different size. That's your key definition. I'll write that down if you want to. That's a top trick. It's different from the word congruent, which means same shape and same size. Anyway, this is a different size. Look at the length of PR. Now, PR is this length over here. Let's do this in yellow. We want to find out what PR is over here. Now to do this, there are 3 steps. The couple of steps we need to know before we actually do or apply the calculation. The first thing is to identify 2 separate shapes. So I think this is good enough. We have 2 shapes over here. So we don't need to actually apply anything to that, okay? Because sometimes we have a combined shape and we need to find the 2 shapes, or identify it rather, from a big combined shape. Here we're given them already. They're 2 separate shapes. Step 2, let's find a scale factor. You may have heard of that word before. So let's calculate a scale factor. So a scale factor is basically how you get from one shape to another. Now to do that, let's call this shape A and shape B. You should always identify them with 2 different things. Scale factor is defined as basically it's well, before we do that, we're going to find like-for-like sides, okay? Like-for-like sides mean we need to find the same side lengths which are known on the same bit, okay? So if PQ is known, which is 15, AB is known as well, that's 6. So these are like-for-like sides. They're both on the same bit of the shape. Scale factor is basically going to be this. Once you've got those like-for-like, we do this. It's B divided by A. Okay, so B basically is 15. And A is 6. How many 6's go into 15 in this improper fraction? It's 2. Remainder 3 over 6 can be written as 2.5 or 2.5. That's your scale factor, which means every side length from shape A can be multiplied by 2.5 to get to B, to give you that side. It's also worth mentioning, it's not necessarily the largest divided by the smallest. Some people think that. It's always the right-hand side shape divided by the left-hand side shape, okay? The right-hand side shape, B, could be a smaller shape. We don't know. That's why it's always B divided by A. That's your definition of your scale factor. But always label it A and B anyway, whatever you find best. Another way of doing step 2, by the way, is method 2, let's say, for the scale factor. Some pupils prefer it like this. This is called the lower upper bound method. So they may say, okay, how do we get from 6 to 15? Well, what do we know? It's 6 times 2. That's your lower bound, 2. That's 12. Let's do 6 times 3. Trial and error, in fact. This is 18. We want to get to 15 because that's what it says over here. So that's exactly 3 here and 3 here as well. Plusing 3 minus 3. So this would definitely be, if that's bang in the middle, this would be 2.5, and that's your answer. Another way of generating the scale factor. Step 3, let's apply this to the question. So PR is this length. So 16 times 2.5 would give you any side length of this shape B. So that will basically be 16 times 2.5. So we'll basically do it like this. We'll do long multiplication using obviously this as 1dp here. So 6 times 5. Well, we won't do it now on the video, but you should know it'll be basically how to do this. And the answer would simply be 40, just to save a bit of time here. So 40 is PR, but I'm sure you can do that in your own time. Alright, let's do part B. Now, to find BC, we're going to be doing this. So BC is, here we go. So BC is this length over here. Let's use a different color. Let's use maybe green. This is a like for like 20, and you want to find out this BC to make it like for like here. So how do we go about this? Well, we'll divide, okay? How do we divide by these numbers over here? So it's going to be 20 divided by 2.5. Notice how we wrote a fraction over here. Now, what is wrong with this bottom number, this denominator? We have a decimal here, so we can't have this. We've got to make it to a whole number, the denominator. We times it by 10, the top and the bottom. So this comes 25, this comes 200. This is how you divide by decimals, by the way. How many 25s in 200? That would be 8. So your answer over here would be 8, and that would be it. So again, look through these questions, part A and B. We're showing you key and non-calculated techniques of how to deal with multiplying and dividing by decimals. That's the key objective really you should have got out of this. And those are your 2 answers here and here. The 3 steps as well. Let's press pause, write this question down, and press play when you have finished this. So this question is integrating many of the principles we have learned before. Let's delve into this straight away. So AC, BD, and EF are parallel lines. We see AC, BD, and EF all with arrows on them. And we could say that ABCD is a parallelogram. So this green one over here as well, the top one, is a parallelogram. Well, we also see a trapezium at the bottom and an isosceles triangle as well, with these 2 things on this far right one. Look at the angle X. So X is this orangey one over here. Let's look at angle X. What do we know so far? Let's try to look at this in the big picture and look at any angles we should know. Now, this trapezium over here, this straight away tells us these 2 add up to 180. Okay, so this has to be 180 take away 119. So if we do that, a bit of mental maths over here. 10 take away 9 is 1. 7 take away 1 is 6. So it's 61. This is 61 degrees. Okay, angle BDF. What else do we know from here? Well, this parallelogram, we could say as well, these 2, 128 plus something, will give us 180 as well. They're both supplementary. So 180 take away 128, this will give us 52 degrees in the same way we did before. I didn't do the working out there. Now, how do we find out this? Now, this is an isosceles triangle because we have 2 lines over here. So the question is, how do we find out this angle over here? We want to find out this. If we know this one, we know that this one is the same as well. So how do we do that? So the question is, let's try to figure this out. Now, this is a straight line, okay? We want to find this yellow one over here. A straight line we have. That should be quite apparent because we have FDG being a straight line. So therefore, we could say 61 plus 52 is going to be 113, and 180 take away 113. This will give us the answer for this. So the same way we did before, 10 take away 3, 7, 7 take away 1, 6, 67. This is 67 degrees, angle CDG. I also use triangle, so that's 67 as well, the 2 base angles, these 2 yellow ones over here. And therefore, this top triangle must be 180 take away double this. So 180 take away 134. We got 134 by obviously doubling 67. So this will be 7 over here, a 1, 6, and this will be 6 as well. Sorry, this would be actually 4. 7 take away 3 is 4. 46. So this is going to be 46 degrees, and that's your final answer. So show the working out, 46 degrees. You can't really go wrong with going step by step of what you know from the question. It's very much called chunking, as we do in maths memory. Chunk up the question, look at what you know, and work backwards to get that value of x. Press pause. Let's write this combined triangle down, and let's try to find out the parts A and B of this. Press play when you are ready. Now this question is a typical question on combined shapes, which means we have one big shape and you need to find out the two shapes within this that have the same shape and the same size. That's the definition of similar shapes. So first of all, let's have a look at this. Triangles ABC and ADE are similar triangles. BC and DE are parallel lines. We can see that from these little arrows over here. So AD equals 8.4, AB equals 5.6, BC equals 2.5. Work out the length of DE over here. So before we do anything, let's try to figure out where these two triangles are. Let's just draw the small one and the big one side by side. There's a small one. There's the big one. It doesn't matter the scale of this, as long as you're working out is fine on each one. Let's call this A, B, C. So this is the one on top over here. And then the other one we'll call A, D, E. And it was quite easy to figure that out because obviously our parallel lines are over here. If it helps you, you can put that there as well. Let's try to now label what we know, the known sides of each triangle respectively. So AB, we know that's 5.6. BC is 2.5. We don't know AC. AD, it gives you AD over here actually, 8.4 centimeters. We have AB is 5.6. That's what we already know that. BC is 2.5. Okay, so that's all we know from this. So it's very important to identify and split your two triangles up. That's what we've done first of all. And that's just the setup, let's say, for similar shapes. Also, step 2, you want to really find out a scale factor before we do any of the calculations. Now, scale factor is always going to be this formula, largest divided by smallest of the known sides you have. So over here it's very clear. We have this left hand side, 8.4 and 5.6 known. So before we start, we're going to be doing this. The scale factor is largest over smallest. This will be 8.4 over 5.6. This is non-calculator. Most of these questions and similar shapes are non-calculator anyway. So what is this? Now we can't have a decimal in any fraction, so we can multiply it by 10. Hence, it could be 56 at the bottom and 84. Right, this is a top heavy or improper. How many 56s are in 84? It's 1. Remaining 28 over 56. That's a mixed fraction. That could be written as 1.5 or 1.5. Remember, 1.5, 2.5, 3.5 always come up in similar shapes, non-calculator. So we've got step 1, we've identified our separate triangles. Step 2, we've got our scale factor. Let's go now for the calculations. Part A, we'll get a length of DE. DE is over here. We need to be a master in how to multiply and divide decimals on non-calculator, the technique on those versions. So 2.5 will be times 1.5, because how do we get from the small to the bigger triangle? You always multiply. So from here to here, we always multiply, okay? Multiply by 1.5. And from here to here, you guessed it, we divide by 1.5. A question will always ask you timesing or divide. That puts things in context. Let's do this. 2.5 times 1.5. So we'll simply do 25 times 15. And this is long multiplication. Remember, we can never have decimals when we multiply. So we're writing 1 dp here and 1 dp because we've moved the decimal to the end over here. The answer will be go back 2 decimal places because 1 plus 1 is 2. 5 times 5 is 25. 2 times 5 is 10 plus the 2, that's 12. Put a 0 here for long multiplication. 5 times 1 is 5. 2 times 1 is 2. Let's add these together over here. So we get 5. We get 2 plus 5 is 7. 1 plus 2 is 3. Let's go back 2 decimal places. So we go back 1, 2. 3.75 is the final answer. So this is 3.75. That's the answer for DE. Alright, so that's the answer over here. Let's have a look at this. So now AE is 9 centimeters. So AE is 9 centimeters there. Work out the length of CE, which is over here, a small bit. Now to find out CE, surely let's find out the whole thing, which is, well, let's find out in fact AC over here, okay? Because once you've got AC, we can take away AC from 9, okay? AC from AE. So the question is, what is AC? Now, AC is this line over here. It's a smaller triangle on the right-hand side. Let's go backwards, divide. So if you look over here, we're going to be doing this division by decimals. So 9 divided by 1.5. All right, now we want to multiply this by 10 because we can't have decimals in a fraction. 10 as well. We get 15 over here, and we get 90. So how many 15s are in 90? This is quite simple, in fact, it's 6. So AC equals 6. If AC equals 6, CE must be 9 take away 6, hence 3. So if you can see this underneath here, CE must be equal to 3 centimeters. I'll put centimeters there as well. That was DE. Alright, so pause this. Make sure you get this. It's a very, very typical question on calculator. The trick are the techniques in multiplying and dividing by decimals. But make sure you have your setup straight away, as we talked about separate triangles and a scale factor before we do any of these calculations. Press pause, write this question down, press play when you're ready for parts A and parts B. So this question we're going to call the LAB table, and how do we interpret this? We look at these keywords over here, mathematically similar. So this means LAB, and we're going to show you a really good way of creating a table from this. LAB stands for length, area, volume, you've guessed it. Now the way we identify this is we see two shapes over here, two 3D shapes to be exact, one smaller one and one bigger one over here, okay? There's two similar shapes, but they're the 3D version. Now let's create a table before we start anything more from this. Now the table looks a bit like this. We're going to call this LAB over here. So LAV, lab. And we're going to just do a few things over here to make it look a bit better. Lab over there. This over here. Okay, we're going to make it look like that. So 4 columns, 3 rows, and we're going to call this, in fact we'll do another row over here as well. So 4 by 4, how about that? And we're going to call this one over here, before we start, times r squared, times r cubed. So r stands for your scale factor, or ratio to be exact, r for ratio. And the golden rule is we want to find out this golden square over here first. Always find out r. Now let's fill in what we have. First of all, let's call this A and B, because we have A and B simply over here and here. Now, what do we have over here? What lengths do we have? We say that these two bases, widths, these are 3 and 6 respectively. This must be 3, this must be 6. Let's fill in the gaps as well. Surface area of A surface area, same thing over here. We're going to put this as 50. Anything else? Do we have any volumes? Not as yet. So part A is saying find the surface area of B. So once you've filled in the LAB table, we want to find out this box over here. Now, as we said, let's find out R first. We've filled out the table. Let's find out R. Now R is a ratio that separates 3 and 6. It's multiplying a number. It's very simple. It's times 2. Now once you've got R as 2, obviously, personally, we just fill in this straight away before anything else happens, before we forget anything. Because R is 2 to the power of 1, 2 squared, 2 cubed, respectively, for LAV. So 50 times 4 squared, 4 is going to be 200. And that's the answer for this one over here. 200 and 200 we're going to write over here as well. 202. Part B, find the volume of B is 400. Find the volume of A. So the volume of B is 400. We simply plug in the numbers into the LAB table. That's how simple this is. Your answers will always be churned out from the table itself. That's why we fill in the table first. So if something times 8 gives you 400. 400 divided by 8, 50. That's a coincidence. Both of these are 50, by the way. 50 centimeters cubed. That would be your final answer for this. So that's how you do the LAB table for the questions involving things like this. Press pause. Let's draw this parallelogram down and let's identify these two shapes and prove that they're congruent to each other. Press play when you have done this. Now, ABCD is a parallelogram. It'll always give you a shape in these congruent or proof questions. And the trick really is to really know the key characteristics or features of this shape that they give you in the question. Anyway, E is the point on where diagonals AC and BD meet. E is over here. Prove that triangle AEB, this one over here on the top, is congruent. Congruent means same shape and same size to DEC. So we'll put them in two different colors like this. There are 3 steps in this process. Step 1 is to identify your shapes, which we have over here. So we'll put identify shapes, which happen to be triangles in this case. In most of these questions, they are triangles anyway. Step 2, we really want to get down to this now. And there are 4 types of different, well, a bunch of letters, should we say, in terms of SSS, SAS, ASA, or RHS. All right, those are the ones you need to really look at and choose one of those to prove this. Now, that sounds complex. What you need to do is look at these 2 congruent shapes and to pick out straight away the key features you see from this shape called a parallelogram, obviously, okay? And you're not meant to know what SAS or whatever it may be beforehand. You're meant to slowly derive these from basics. So the first thing, what do we look from this? Now, a parallelogram has 2 parallel lines, AB and DC are parallel, and so are BC and AD. So we can look at S first of all, and write S here. So side equals side, we could say. Therefore, AB equals DC. All right, AB is this top line in yellow here, and DC is the green one. So it's very important to write down the specific letters from the original shape. That's the first one. So S we have found out from this. Again, let's look at these 2 triangles and see what else meets the definition of congruency over here. Is there an S or an A we could justify? Now looking at parallel lines, again, let's hold on to this 2 arrows meaning parallel lines. We could say that these 2 angles over here, let's say this one, BAC, and this one, DCE, they are alternate angles, okay, from the idea of parallel lines. So we could put an A here, discover that, and say just that, BAC equals, let's say, DCA. Okay, that's from alternate lines. Really, approximately, if I had this and this, these 2 over here, remember, would be alternate, those ones, like that. Let's now look at the next one. Let's see what else we can derive. I mean, you can also do another one over here. The same idea, in fact. This one over here. We can say this one is alternate to this one over here. So another A we've picked up, which gives us an idea of what this is heading to. So this, again, the blue one, would be ABE, okay, would equal CDE over here as well. We'll put them in 2 different colors so you can identify that. That's this one, and this is this one over here. And it's very important to justify this. This is step 3. So step 2 was really choosing the ones we need. So this whole thing over here was to choose. Step 2, I write that, you choose your type. Type means one of these 4 things over here, okay, in terms of SSS, SAS, let's say AAS, and RHS. And the one we chose over here was 2 angles and an S, so the one we chose was this one over here, AAS. SAA, doesn't really make a difference which order it's in. Step 3, let's justify this. So step 3, we're going to justify the answers over here. Justify just means now, after each one, we put a little bracket and justify why we chose each one. You need to be a bit more specific here mathematically and justify it in relation to the original shape and the question itself. So AB equals DC. Why is these? These are 2 parallel lines, okay, from a parallelogram. Now, I won't write in detail what you need to write for the exam, but just the general basics of this. Okay, so these are parallel lines. Okay, parallel lines from parallelogram. Okay, these are the key words from this. These ones, these are again alternate angles. You can write Okay, so 2 parallel lines, and again alternate angles over here. Okay, so you've justified each one. That means in a bracket, and therefore the answer is SAA. Or you could say AAS. It doesn't really make a difference. That is your final answer for this. The 3 steps, going back again, we got identify shapes, choose your type, and justify it in the brackets. And there's your final answer for this. It could be a different answer if you justify it correctly, by the way. But here we've basically just looked at your 2 shapes, and we've just looked at the key characteristics, and individually in turn stated what each one was. SAA in this case. Question 9, Core 9 Gold Geometry. Let's press pause. Let's try to answer part A, B, and C in this gold question. Press play when you're ready. So a regular hexagon, a regular means the same sides or same angles of any polygon, is inscribed in a circle. If the perimeter of the hexagon is 30 centimeters, find these 3 parts. Okay, so the radius of the circle is first. So the radius is defined basically from the center to the edge. So there are 2 ways of doing this. We're going to do an intuitive way first, and then we're going to show you the way in the exam. Okay, so let's do the intuitive way first. So if all 6 sides of this regular polygon, if it's regular, add up to 30, 30 divided by 6 would be 5. So each one of these would be 5 centimeters over here. Okay, 5 centimeters. 5, 5, 5, 5. The question is saying to find out one of these lines over here, or the radius rather, as such. So what is one of these lines over here? We need to find out these ones. Okay, now the way to do that is we could say that any circle adds up to 360 degrees. We could say all of these add up to 360. Okay, now 360 divided by 6, because there's 6 equal triangles over here, it gives you 60 degrees. So this has to be 60 degrees over here. Let's look at this triangle, okay? Now that's 60 degrees, and these 2 lengths are the same, okay? Because they're the radiuses. Radiuses mean same lengths. Therefore, it forms an isosceles triangle. Hence, these are the base angles 60 and 60, if you want to flip this around, okay? Hence, these are 6 equilateral triangles in a hexagon. In fact, any regular hexagon will be equilateral triangles. If that's the case, if the base is going to be 5 over here, surely everything will be 5 as well. This will be 5, this will be 5, everything will be 5, and that forms the radius. So that's the intuitive way. The radius is going to be 5 centimeters, okay? We did it 360 divided by 6 to give you 60 degrees. We talked about equilateral triangles, okay? And there, so the answer will be 5 centimeters. Now there's a way in the exam to do it as well. This is the way over here. So the perimeter is defined as this. Okay, so this is the perimeter of a regular polygon. So this is a P equals 2nr sine 180 over n. Let's plug in a few numbers over here. So the perimeter is 30, 2 times n. N is going to be 6. We don't know what r is yet. And this is 180 over 6, okay? So that's 30 equals, let's say 12 sine 30 over here. Sine 30 is a half, okay? So we could say basically that 30 equals, let's say, this will be r, by the way, I forgot to put r here, it's 12r. 12r times a half, okay? Which is the same thing as saying 30 equals 12r over 2, then we can cross multiply over here. Cross multiply, meaning 60 would equal the same thing as 12r, and r would be 5 centimeters, the same thing as the snap above. Okay, so that proves part A. The radius is going to be 5, only from rearranging this formula of perimeter of a regular polygon. So that's part A over here. Let's do part B part B is really easy. Once the radius is 5, pi r squared is defined as the area of a circle. Pi times 5 squared, which is 25 pi centimeters squared. Okay, so that's the area of part B of a circle over here. Okay, let's move on to the next one. Let's move on to part C, which is the area of a regular polygon. So if we look at this, let's split this into 2. So again, let's do an intuitive way over here. So the area of this polygon, let's look at this as the sine area rule. Okay, let's call this 60 degrees. let's call this 5 centimeters and 5 centimeters as you've done before. This is the green triangle over here. So in fact, it can be called green. It's the same one as this one over here. Same one as that. All right. So this is like side angle, side. We know the side angle 60 degrees and side. If you have side angle side, you can work the area within this. You can say it'll be half times sine A times B times C, which basically is saying it's half times sine 60 times 5 times 5 times 25. Sine 60 is root 3 over 2, so we have root 3 times 25, and this whole thing is going to be 2 over here. So basically it's going to be 25 root 3 over 2. Let's times that by 6 now. Okay, we're going to times it by 6 because there's 6 equilateral triangles. That was one equilateral triangle. So we have 150 root 3 over 4. In fact, I made a mistake over here. This should be 4, in fact, because this is going to be root 3 over 2 times a half. So my apologies, this is 4. This is 4 over here. So this will give us 75 root 3 over 2 centimeters squared. Okay, that's how we do this. If you wanted to, I should just put this step here as well. I should have put half times root 3 over 2 times 25 over 1. That's how I got to this step below that. All right, so that's how you do it using this technique of SAS sine rule over here. Now again, there's a way to do it in an exam, and this is the way of doing for the area of a regular polygon. Okay, so this is defined as this. So if we have enough space over here, I'm going to write it over here, in fact. Give myself a bit more space like this, as such. Okay, so this is going to be defined as this. So we're going to be defined, the area is defined as A equals a half n r squared sine 360 over n. Okay, so the area is going to be basically a half times 6 times 5 squared times sine 360 divided by 6 is sine 60. Okay, so we're going to put that over here. So this is the same thing as saying half times 6 is 3. 3 times 25 is 75. 75 times root 3 over 2, which is the same thing as saying 75 root 3 over 2 centimeters squared. There you have it again. So you have two ways of finding out the area of a hexagon. Okay, using n. It could be any n-sided polygon. That's regular, by the way, but that was the first one we chose over here. So if you know these two formulas, the perimeter and the area, you can't really go wrong. But we showed you the intuitive way and the way in the exam to back it up for the perimeter and areas of regular polygons in this question. Press pause, write this question down on LOV, press play when you are ready. So this question is about LOV again, and it's a bit more wordy. Let's read this question over here. So solid A and solid B are mathematically similar. That interprets it to LOV table. The ratio of the surface area of A and the surface area of B is 4.25. The volume of B is 1250 centimeters cubed. Show that the volume of A is 80 centimeters cubed. When it says show in the exam, don't actually look at that first and try to work something out. You're meant to derive it from what you have in the question already. So don't look at this thing saying volume of A is 80. We're trying to make it look like 80 from this question in the yellow bit, and we're going to place snap at the end, and 80 should equal 80, if that makes sense. So first of all, let's draw this LOV table. We should look forward to these LOV tables because this is a sure way of understanding the length, area, and volume principles. So LAV, this is going to be 4 by 4. Let's do these things over here. So we have first row, second row, third and fourth row. And let's put the columns as well. First, second, third, fourth. So these two shapes over here, they are called A and B. A and B. Again, let's do our ratios for length, area, volume times R squared times R cubed. And you've got to find out the golden square, which is obviously this one over here, times R, let's say. Let's fill in the blanks. What do we know from here? Do we know any information about anything so far? So the ratio of the surface area of solid A 2b is 4 to 25. So that means it's not specifically saying that the errors, or service errors rather, are 4 and 25, but we can interpret from that if this is 25, this would be 4, because 25 divided by 4 equals r squared, i.e. that's your relationship over here. So r squared would equal actually 25 over 4. That's what r squared actually is. Let's find out this over here. So r could be the square root of that to get to r, which is 5 over 2. So r is 5 over 2. Let's get r cubed as well. So if we cube the 5 on top of here, we get 125. And we cube the 2, we get 8. So that is your r cubed on this. So the question is asking us to find out the volume of A. Prove it's 80. Well, before that, the volume of B is 1250. So this is 125 over here. Let's try to get to this square over here. We want to get to this square of the volume of A. So obviously, we want to divide 1250 divided by 125 over 8. Now go back to year 7. Let's try to divide two fractions. 1250 over 1 times. We flip this, remember? We flip that. 8 over 125. So if we do this over here, 1250, well, we can cancel a few things before we do this, can't we? Let's cancel this. Let's divide this whole thing by 125 and 125 over here. So 10 times 8 over 1, and this will be 1 over here as well. Well, the answer, top times top, bottom times bottom, 80 centimeters cubed. So there we have it. It's snap, S and S. There's two things here. We have a answer of 80 centimeters cubed, which matches this original hypothesis in the question. And that's how you do the LADV table for this kind of scenario.